Okay, welcome to Graphing Trig Functions, which is section 13.4 in our book. So, before we go any further, I want you to hit pause and I want you to copy down the sketches here that we have for sine, cosine, and tangent. Okay, go ahead and do that. Alright, so hopefully you have copied these by now. So, understand that sine starts at 0, 0. Goes up to its max and then comes down, okay, and completes its full cycle. Cosine, on the other hand, starts at 1, right, and then drops down and forms that cup shape, okay? Just remember the C in cosine is like the C in cup, okay? So you have to know what that looks like in case you don't have a calculator. Notice how with both sine and cosine we have a max of 1 and a minimum of -1. Now, tangent, we have vertical asymptotes. So the tangent function is not continuous everywhere, all right? It approaches the VAs, all right, and is never going to cross over that line. All right, so there are some values where the tangent is undefined. All right, so the first one here, if we're just looking at positive territory, is pi over 2 or 90 degrees. So if you were to punch in the tangent of 90 in your calculator, you would see error. Or the tangent of 270, right? It would say error. Or -90 or -270, okay? So these are the basic shapes of sine, cosine, and tangent. And so you have to know what the general graphs look like. So let's talk about some vocabulary terms now. Okay, first term to discuss is the term period. This is the length of one complete cycle. So if we were to go back up here to our sine curve, the period is 360 degrees or 2 pi. All right, so the curve will start to repeat itself after 360 degrees. Same thing is true with cosine. The period here would be 360 or 2 pi if we were in radians. So once again, the idea is if you were to complete a full cycle, that's how much time would be needed in order to do that. Okay. So down here with the tangent, the period is not going to be the same. The period here is 180 degrees. So if you look at the distance between these asymptotes, all right, this distance between 90 and 270 is 180. All right, so that would be the period or the length of one cycle. So by length, we're really talking about the x values, which is really the angle, okay? Or sometimes we think about it as the amount of time to complete one full cycle. All right, next we have amplitude. So we have a pretty simple definition here for amplitude, a nice little formula which will come in handy later on. So it is 1/2 the max minus the min. So you have to commit this to memory. This is not given to you. So the amplitude for this basic sine curve would be 1. All right, if we were to look at this distance here, all right, between the max and the min, okay, this vertical distance, all right, from 1 to -1, that vertical distance, of course, would be 2. Half of that would be 1, okay? So it's really the distance here from the, in this case, the x-axis up to the max, or the x-axis down to the min. Okay, so those are each a distance of 1, okay? Same thing is going to be true over here with our cosine curve. Our amplitude would be 1. Same idea if we were to look at the distance between the max and the min. Okay, so here's our max, here's our min, right? That distance would be 2. If we do half of that, all right, we get 1. So it's half the distance from the max to the min. Now down here with tangent, since there's no max and there's no min, since it goes up and down forever, we say that we have no amplitude, okay, because we can't do a max minus a min if they do not exist. All right, and finally we have what we call the horizontal, or sometimes we call it the principal axis, okay? So here, there's a formula. It's 1/2 the max plus the min. So what are we talking about? What do we mean by a horizontal or a principal axis? Well, we are referring to this horizontal line that goes right through the center of your trig graph. So usually it's going to be the x-axis. All right. Think of it as the average of the max and the min, right? The whole idea of 1/2 the max plus the min, that's simply the average of the max and the min. All right, so it's exactly in between the max and the min. Okay, so we call that the horizontal axis or the principal axis. So in this case, it would be y equals 0 for each of these, right? Y equals 0 is the same as the x-axis. Now down below here with our tangent curve, it's not really applicable since we don't have a max and a min, okay? But usually we just see the x-axis here, or again that line y equals 0, as our principal axis, okay? Or in other words, just as the center line, okay? Again, it's not technically a center since we don't have a max and a min, but you could just think of it as a line in the middle, okay? All right, so how might we see this applied? Well, one way is to have an equation that we're solving, and we're allowed to use a calculator, okay? And we are going to focus this time on the technique of solving graphically. So we're going to be using the graph and using the calculator to help us solve this equation so we don't have to go through the algebra that we went through last time, okay? Now notice this equation, cosine of theta equals 0.4. We would not be able to solve this one without a calculator, okay? The equations we saw before worked out nicely because we weren't allowed to use a calculator. So, to solve something graphically, well, first of all, it just says to solve, and we want to do it to the nearest tenth, okay? Since you're allowed to use a calculator, all right, write yourself a note that you should solve graphically. All right, so even though it's not saying, hey, solve this graphically, if it's just saying to solve and you're allowed to use a calculator, this is the technique you're going to want to use. Okay, so it's saying to do it from negative 360 to positive 360. So that's going to be your x min and your x max in your calculator. All right. What you're going to do in your calculator is we are going to put cosine of x into y1, and this 0.4, you're going to put that into y2. Alright, so now you're going to have to show the sketch on your paper as part of your work. So we know that and if we just set our scale here, we know that cosine is going to go up to 1 and down to negative 1, okay? So that's really your y min and your y max. So if you were to use the calculator, all right, to sketch this out, what you would see is your basic cosine curve, okay? So this is just y equals the cosine of theta, all right? So make sure that since we are doing this in degrees, your calculator is in degree mode. If you are graphing in radians, all right, then make sure it's in radian mode. It all depends on what our interval is here, okay? All right, so my graph on my paper here, or my computer is not perfect. It doesn't have to be perfect. It's just a sketch, all right? So now that's just what I put in y1. Let's put in what we have in y2, which is 0.4. Well, 0.4, y equals 0.4 is just going to be a nice horizontal line. All right, so get that on your paper. That's what we have in y2. All right, so at the same time, you want to have that in your calculator graphed. So we want to know where are these equal, right, between negative 360 and positive 360. Well, you can see that they're going to be equal 4 times. So you want to use the intersection button, which is found under second calc, okay? So we want to find the intersection there. So go through and hit pause right now, and I want you to find those 4 intersection points. So if we let the calculator do all the work for us, we get these 4 answers, and we're told to round to the nearest tenth, so we don't care about 3 sig figs. Nearest tenth will trump the whole 3 sig fig idea. So when we list out our answers, this is what we have, okay, for our 4 solutions. So as far as required work goes, I mentioned you need to have both of those curves drawn, and then you also need to circle your 4 intersection points and then write down the values like I did near those intersection points. Okay. Another option that you could have used if you want was you could subtract over, back up here, you could subtract over your 0.4 and write your equation as cosine of theta minus 0.4 equals 0. And then if you were to graph that, you would just have a single curve. And if that were the case, you're looking for the roots or the zeros or the x-intercepts, right? You'd get the same four answers, but your graph would look different because, again, you'd only be looking at one curve. So either way, you want to make sure that you are taking advantage of your calculator and solving it graphically. All right, last example. And hey, wait a minute, this is the same example. Well, suppose this time you just have decided, you know what, I think solving graphically is stupid. I don't want to solve it that way. You're still allowed to use a calculator, okay, but suppose you want to use it in a different manner. So, same problem, okay, but if we are looking at this right here, cosine of theta equals 0.4, and we're trying to solve for theta, to undo our theta here, what we do is we use what we call inverse cosine. So on your calculator, you'll find the inverse cosine above cosine. So if we do inverse cosine of 0.4 in our calculator, so if you were to do that right now, you would get 66.4. So because we're talking about cosine being positive, all right, we have to remember ASTC. So this 66.4 is really our first quadrant angle. We know that cosine is also positive down here in the fourth quadrant. Again, we care about why or where it's positive because 0.4 is positive. So you would have to then do 360 minus 66.4. That'll give you the answer we saw before of 293.6. Now this will give us our answers from 0 to 360. To back it up a cycle, we need to simply do 66.4 minus 360, and then the 293.6 minus 360. So remember, subtract your angles from, or subtract 360 from your angles to back it up a cycle. So then you would get your negative 293.6 and your negative 66.4 that we saw in the previous problem. Okay, so you would still have, I'm not going to write it again, but you would still have your four answers from before. All right, so just another way of looking at it. However, you will see some equations that you're solving where it's just too complicated and you are not able to use this technique of undoing the cosine. This is called the inverse cosine, by the way, right? That -1 notation means inverse. That's how we undo a regular cosine. So be aware that you are going to have to still solve it graphically sometimes. You're not always going to be able to use this inverse technique. So that's all for now.